Hey, so if you think back to how we define constructors for our classes, you'll remember that we can construct the base class part of some derived class. If you remember, you can do that in the initialization list of the derived class constructor. And you'll remember I talked about the order in which the constructors and destructors will get called. The destructors are automatically called in the reverse order of the constructors. But the main point with this difference is that we as programmers define the constructors for the derived classes and which version of the parent constructor to call. That is to construct the base class part of a derived object. Destructors are a bit different. All we're going to do is we're going to specify what we want to deallocate in the destructor. So we don't use virtual constructors in C++, but we do use virtual destructors, and they are quite important. And typically if a class has a virtual function, then you must also define a virtual destructor for the class. With a virtual destructor, the parts of the derived objects will be destroyed in the correct order. Okay, if you don't have a virtual destructor, the behavior is actually undefined, but what it boils down to is that you risk destroying only the base class part if you don't provide a virtual destructor. Another interesting note is that if you provide a user-defined virtual destructor for the base class, then derived class destructors are defined as virtual automatically. So in other words, you don't have to specify them as virtual, but you can specify them as virtual in the derived classes to make it clear to the reader or the programmer that the destructor in derived is virtual. You can see an example at the bottom, the virtual destructor syntax. You simply have the virtual keyword followed by the usual destructor syntax. Quick example for you: in Visual Studio I have the base class, and in the public section I have the destructor. And all we're going to do in the destructor, so when we destroy an object of type base, we will print out base destructor invoked. Then I have the class derived, which again publicly derives from the base class, and I also have a destructor for this. And when the destructor is invoked for an object of type derived, we print out derived destructor invoked. Then in main I have these two pointers again, base pointer and base pointer 2. As in previous examples, those are pointers to type of base, and in the first statement I allocate an object of type base on the heap, whereas base pointer 2 is going to point to an object of type derived on the heap. Eventually we want to deallocate those objects on the heap, so we do delete base pointer and base pointer 2, which will deallocate the object of type base and the object of type derived. Now what happens if I build and run now? Remember that those destructors are not virtual in this first example, so we get base destructor invoked twice. Now if you think back for a second on our discussions on inheritance, you will remember that the derived object is basically made up of or composed out of the part that is specific to the derived object, as defined in the derived class, but it also has a base part, and your destructors are going to be responsible for cleaning up the particular part. So the single destructor is not going to destroy all of the parts unless it's simply the base class destructor, and we can clearly see the problem here is that we do not clean up the derived part. In both cases we only clean up the base part. So let's go and fix that. So I'll use virtual destructors. Now you can remove this here. You don't have to add the virtual keyword in the derived for that to work. The destructors in the derived classes will now be virtual. Build and run this, and I'll show that to you. And as you can see, we get base destructor invoked. That's fine, that's for destroying the first object pointed at by that base pointer. But then we destroy the base pointer 2, which points at an object of type derived. And in that case, what you want to do is you want to clean up both parts, the part that is specific to the derived object, and also the base class part as I mentioned, so the derived destructor is invoked and then the base destructor. But just to make it clear to the reader, to the other programmers and so on, that this is a virtual destructor, I prefer to write the virtual keyword here, that is in the derived classes, and the same thing with virtual functions actually. Alright, so let's go and build and run this one final time, and you can see we get what we expect, base destructor invoked. And then when we deallocate whatever base pointer 2 is pointing at, which is a derived object on the heap, that object is gonna get destroyed, and we clean up both the derived part and the base part. So derived destructor invoked and base destructor invoked. I hope this simple example demonstrates why this is important, why it's important to have virtual destructors. And it's often the case that when you have virtual functions, but you don't have a virtual destructor, that will get some sort of warning. So when you use virtual functions, also go and define a virtual destructor. And of course this becomes very important when you have member pointers, where those member pointers may point to dynamic variables on the heap, and your destructors will then be responsible for cleaning those up when those objects are destroyed. So again, simple examples here, but you can think that this can get really important, especially when you use member pointers.